Good morning, Miss Kelsey.
Good morning.
How was the homework last night?
It was good. I got it.
It takes some practice.
Yeah.
Did you do some of them in the book and then try the ones on the my math lab?
Yes. I did good on the math lab. At first, I did get confused because, like, the graph, you had to click on it for, like,
Yes.
the line to show up and then that to pop up. So I was
Yes.
like, I don't know. So it took me a few minutes to do that.
Yeah. It's pretty cool, though.
And I also got confused with the range. I was like, it's the Y's. And
Right.
then I had the right parentheses around them.
Oh, because you're writing it in interval notation.
Mm-hmm.
Ah, yes.
But I caught on to that.
All right. I figured anything that bugged you at first, you'd figure it out. Good morning, Miss Carly.
Good morning.
How'd you do on the homework last night?
Pretty good.
Good. Good. Well, we're going to start with only 3 people. Do you have any problems that you needed to see from the book on page 383-ish?
No, not really.
It was also a little bit challenging to check your answer in the back of the book because they just did it differently. If our endpoints ended up being at pi over 6, then we just labeled our tick marks counting by pi over 6, and they labeled their tick marks always, I think, counting by pi's, and so it was hard to tell where pi over 6 was and pi over 4 was. That was a little bit difficult, but the test will be in my math lab like the homework was, so make sure you can use those tools for graphing. For tonight's homework, actually, I want you to do some graphing on paper. I'm not completely through with this, but I'm going to email you a worksheet that looks like this, and I'm going to give you till Monday to do it. But I'm going to ask you several questions. I'm going to give you a graph. I'm going to ask you for the general shape of the function, and I'm just talking about the button that you click in my math lab. For sine, it looked like this. For cosine, it looked like this. I don't know if it'll have a button for tangent and cotangent, but we're talking about those today. And so give me basically what the basic graph is supposed to look like, and then the amplitude, the period, the endpoints. Show your work when you set up that inequality to find the endpoints, the midpoint, the x-intercepts, and then graph the function. And if I give you, I'm thinking about giving you a graph that does count by pi's. And I may change my mind on that, but what I'm thinking is giving you a graph that starts by pi's, and if you need to count by 1/3 of a pi's, just say, you just add your own tick marks, 1/3, 2/3, 3/3, 4/3, 5/3, 6/3, like that. Would that work? Ladies, does that make sense?
Yeah.
Okay.
Yeah.
All right. Well, that's what I'm thinking about emailing you as soon as I'm thinking of doing one trig function. So I have sine and cosine. I'll add a tangent, cotangent, secant, and cosecant, and then email that to you, and you'll have till Monday to get back to me.
So will we scan and turn that in?
Scan, take a picture, whatever you need to do.
Okay.
Are you able to do that?
Oh, yeah.
Okay. Miss Kelsey, you can do that?
Yes.
Okay. All right. That'll be fine. And then I'll just put your homework in your grade in my math lab after I look at them. All right. So let's talk about the graph of tangent, cotangent, secant, and cosecant. Y'all have watched this video, right?
Mm-hmm.
Okay.
Yes.
All right. So just help me review a few things. Actually, if you've watched the video, you have this whole first page filled out, don't you?
Yes.
Okay, then just as a quick review, let's copy over our summaries here on the back. Oh, it drives me nuts that this camera works mirror image of how I want anything to go. If I want to move it to the left on the camera, I have to actually physically move it to the right. Whew, makes me dizzy. Okay, remind me with tangent. We know tangent is sine over cosine. So where is it going to have its vertical asymptotes? Wherever, which one is 0? Where is tangent undefined?
When x equals 0.
When your x coordinate equals 0, that's when cosine equals 0. So where does your x coordinate equal 0? Whole pies or half pies?
Half pies.
At the half pies. And technically, we have to say the odd half pies because the even half pies are actually whole pies. And instead of midpoint, I guess it's okay to call it midpoint. Let me dash in a few vertical asymptotes here. When I say midpoint, I'm talking about the point in the middle of the two asymptotes. I could also call that the x-intercepts are at the whole pies, because that's where sine is 0. And what polynomial function does tangent look like between its asymptotes? When you just graph tangent, if you didn't have any labeled tick marks, you might think it was what polynomial? What does that look like? This kind of looks like x squared. Not really, but you can squint and play like. What does that look like?
The x cubed.
Yeah. And then cotangent kind of looks like y equals negative x cubed. Now, I'm certainly not saying they're the same thing. I just mean if you had to compare it to some polynomial function, what would you compare that to? And it would be x cubed. And that would kind of look like negative x cubed. This is actually tangent, and that's cotangent. So between its asymptotes, it basically looks like this. How wide of an interval does it take for tangent to do its whole thing, its whole x cube looking thing? What's the period of tangent?
A whole pi.
Mm-hmm. 1 whole pi is the distance from negative pi over 2 to positive pi over 2. It's also the distance from pi over 2 to 3 halves pi. Every whole pi units, tangent's going to do its whole thing. So like we did with sine and cosine, if we choose what we're going to use for one period of the function, it kind of makes sense that we would choose that one that goes through the origin. And so to find one period of the function, to find actually with tangent, I'm going to say this is your left and right asymptotes. Just set the argument between negative pi over 2 and positive pi over 2. So you give me a graph of tangent that's been shifted somehow, and I'm going to set its argument rather than setting the argument between 0 and 2 pi like I did for sine and cosine. I'm going to set it between negative pi over 2 and positive pi over 2. All right, and then for cotangent, to summarize it, we know cotangent is cosine over sine. So where is it going to have its vertical asymptotes? wherever what is 0.
Sine is 0.
Yeah, wherever sine is 0. And is that half pies or whole pies?
Whole pies.
That's whole pies. So it's going to have a vertical asymptote on the y-axis and at 1 whole pie and 2 whole pies. And between its asymptotes, cotangent kind of looks like negative x cubed. It goes downhill from left to right with the midpoint or the x-intercepts at the half pies. So if we had to choose what to use for one period of tangent or cotangent, we would use between 0 and pi. All right. Any questions about tangent and cotangent?
I do have one question.
Yes, ma'am.
It's on the back of the notes.
Okay.
Like tangent. You was talking about between negative 3/2 pi to negative pi. It's in quadrant 2.
All right. Negative 3, because we're going backwards. If we're counting backwards, this is negative pi over 2, right? We're counting this way.
Yes.
This is negative pi, and this is negative 3/2 pi. So you're saying between negative 3/2 pi and negative pi, that should be quadrant 2. Did I say 3 on the video?
No, you said 2.
Okay.
Does
it make sense now if you're counting clockwise because those angles are negative?
Yeah, so it would be in quadrant 2.
Yes. From here to here, from negative 3/2 pi to negative pi is quadrant 2. And from negative 2 pi to negative 3/2 pi, well, here's negative 3/2 pi, that would be negative 2 pi. This would be quadrant 1. This would be quadrant 3, because we're counting backwards.
Yeah. Okay, that makes a lot more sense.
Okie doke.
Yes. Thank you.
You're welcome. Any other questions about tangent and cotangent? All right. Let's do our summary of cosecant and secant. Cosecant is 1 over sine. So where will it have its vertical asymptotes? Wherever what?
Would it be whole pies?
Yeah. Your hesitation right there makes me wonder if you understand why there are vertical asymptotes. Maybe you're just thinking for a second, but let me make sure you understand why there are vertical asymptotes there. When we graphed rational functions, we said rational functions have vertical asymptotes at whatever makes the denominator 0, because whatever makes the denominator 0 makes the whole expression what?
Undefined.
Undefined. So you're looking for what makes the expression undefined, and your vertical asymptote is saying, hey, you can't let x be this because it makes the expression undefined. So here, when I say, where is it going to have its vertical asymptotes? It's whatever makes this expression undefined. It's whatever makes sine x 0. And is that whole pies or half pies?
Oh.
They're whole pies. So I'm going to have vertical asymptotes at all the whole pies. And any, mini, miny, mo, if you said what do you want to use to get one whole period, it would kind of make sense. Let me use my highlighter here. 0 to 2 pi. Now, let me make sure you know why it takes 2 whole pi in order to get one complete picture of cosecant. I'm going to say the left and right asymptotes, we're going to use 0 and 2 pi. For the middle asymptote, I guess I should highlight it too. That's just 1 pi. And then if you think about cosecant, I don't have a big unit circle handy. Let me label these ordered pairs. Ooh, that was kind of messy. Is there any x over y that's going to give you, no, I'm saying that wrong. Darn, what's bothering me? Hold on. I don't know. It'll come back to me in a minute. I'm sure that'll come back. If I have no idea what this graph looks like and I just want to make an XY chart at 0 radians, 0 radians is right here, what is cosecant? Here's the definition of cosecant. What's sine at 0 radians? Which coordinate is sine?
Y.
The y. And so sine is 0 and cosecant's the reciprocal of that. What's the reciprocal of 0? Say undefined.
Undefined.
Yeah, and that's why we have a vertical asymptote right there. Let's figure out what's going on at pi over 2. This is the order pair at pi over 2. What is cosecant here? Nope, I'm sorry, I pointed the wrong place. That's pi over 2. What's cosecant?
1.
Sine is the y is 1, so cosecant is 1. I'm going to plot pi over 2, 1. And then what about at, we know at whole pi, there's a vertical asymptote. What about at 3/2 pi? What's cosecant at 3/2 pi?
-1.
Sine is -1. The reciprocal of -1 is -1. So 3/2 -1 is an ordered pair on that graph. Now, at that point, I have 3 vertical asymptotes and I have 2 points plotted, but I'm not sure what this graph looks like between the asymptotes other than it has that point and that point. Here's what I was trying to think of a minute ago, and it was bugging me. I was thinking cosecant's the reciprocal of sine. So does cosecant have any x-intercepts? The x-intercepts are when y is 0. Are there any of these y's that you could flip and get 0?
No.
No. You flip 1, you're not going to get 0. You flip 0, you're going to get undefined. Flip -1, you're going to get -1. Flip this 0, you're going to get undefined. And that's why cosecant has no x-intercepts. There's no value of y that you can flip and get 0. So that tells me the graph cannot look like tangent, can't look like x cubed, and it would cross the x-axis. It can't look like cube root of x, or it would cross the x-axis. I meant negative x cubed. So there's pretty much only one thing this graph can be doing between 0 and pi if it's not going to cross the x-axis. That's all it can be doing. And between pi and 2 pi, if it's not going to cross the x-axis, that's pretty much all it can be doing. And so the period of cosecant is 2 pi because it takes a whole revolution of the unit circle to get one of these concave up UEs and concave down UEs. Kind of looks like x squared and negative x squared, but it's not. And that's why if you get a graph of cosecant that's been shifted, you set the argument between 0 and 2 pi, because 0 and 2 pi is where you have your left and right asymptotes. Any questions about that one?
No.
All right, one more and we'll have all 6 graphs. Secant x is 1 over cosine x. So it's going to have its vertical asymptotes wherever cosine is 0. And which coordinate is cosine?
X.
That's your x. So wherever x is 0, that's your half pi's where x is 0. So it has the vertical asymptotes at the pi over 2's. Technically, I should say odd half pi's. So there's going to be a vertical asymptote here and here and here. And then what about at 0? At 0, what's cosine at 0 radians? Here's 0 radians. What's cosine? Hey, tell me if something's bugging you, because it seems like it's taking you a long time to answer that. Are you just quiet, or is there something that's making your head frown because I can't see your head?
No, my brother just came in the room.
Okay, let's sign brother up and teach him some trig. That sounded like, dang it. I swear, I think I'd lost my mind. Kelsey.
Yeah.
See, I still have you and Ashley mixed up in my head, and I'm not even in the room. Okay, Kelsey, and Carly, how about you? What's taking you a long time when I say what is cosine at 0 radians?
Well, it was taking me a while because like the screen had frozen for a while. I think my internet connection's not that great.
Okay.
And it just updated, so I was frantically writing everything down.
Okay, so you're not confused then when I say what is cosine at 0 radians? You were dealing with technical issues, not having to think real hard to come up with the answer 1, correct?
Correct, yeah.
Okay, and so if cosine is 1, secant is 1, that means 0, 1 is a point on the graph of secant, and at a whole pi, what is secant?
-1.
-1. So pi -1 is on the graph, and secant doesn't have x-intercepts for the same reason cosecant doesn't have x-intercept. There's none of these x's you can flip and get 0. So if it's not going to cross the x-axis, then it pretty much has to look like that. So for one period of secant, for our left and right asymptotes, we'll use negative pi over 2 and 3/2 pi. For our middle asymptote, it'll be positive pi over 2. Is halfway between negative pi over 2 and 3/2 pi. If you give me a graph of secant that's been shifted, then to find out where the left and right asymptotes have moved to, and of course where the rest of the graph has moved to, I'm going to set the argument between my normal left and right asymptotes, negative pi over 2 to 3/2 pi. All right, so that is a review of all 6 functions. And I just remembered that we had to do examples yesterday because I didn't have the section 5.5 on YouTube, but I did have section 5.6 on YouTube. So you've already seen some examples of those. Do you need to see any, do you need to talk about any of the examples or ask about any of the homework problems?
I don't.
Miss Carly?
I'm good.
Okay, awesome. Well, just hang out. I've got about 30 minutes, so I won't get this little worksheet done before I meet with my college algebra class, but shortly after that, I'll email you this handout. And if you don't have access to a printer, I've got a note somewhere, but I don't remember who can print and who can't. If you can't print, then just copy down the problem and label the parts. You don't have to write down all those words, but label the parts A, B, C, D, E, F, G, and that's just as good as printing it. Okie dokie.
All right.
All right. Y'all have a great day.
Miss Miles,
Yes, ma'am.
what are we going to go over tomorrow? It says 5.6.
Whoa, I looked at that. I thought we had just one day to do 5.6. Hold on.
Well, we have 2 days to do 5.5 and 1 day to do 5.6.
What was I looking at? Dang it, because I looked. That's a great question.
I mean, there's nothing wrong with being red, right?
Yeah. Hold on. Snap, we sure did. I don't know what I was looking at. So today we were supposed to finish 5.5 and tomorrow 5.6. Let's say this. I will check in with Zoom tomorrow morning to see if you have questions from these or any problems you've done on paper. And that's really all we'll do, is just see if you have, if you can either say, hey, I couldn't get number such and such, or I really need to see one more example of cosecant, I just don't have it yet. So we'll just meet and answer questions tomorrow. No more video to watch. Is that okay?
Yep.
Sounds good.
All righty. See you tomorrow.
Bye, Miss Miles.
Bye-bye.